now we come to hexadecimal numbers. Let's refresh our memory for just a moment on base 10. We use base 10, some people say, because we have 10 fingers or 10 toes. What that means is that we have 10 digits or use 10 digits. The decimal digits range from 0 to 9. In this case, we have the number 2048, or a 2 followed by a 0, a 4, and an 8. Now, what does that mean? Well, that means that, beginning with the rightmost column, we have 8 units of 10 to the 0th power, or 8 ones. Then we have a column with 4 units of 10 to the 1st power, or 10s. And we have another column of 0 units of 10 squared, or 100s. And then finally we have, in our leftmost column, 2 units of 10 to the 3rd power, or 1000ths. So we have the number that represents 2048, or in computer language, 2K. So, moving on to base 16, or hexadecimal numbers. This is a number system based not on 10, but 16. Imagine if you had 16 toes, or 16 fingers. The digits for the base 16 begin at 0 and range up to 9. And those are the only characters we normally recognize as numeric digits. But we need another 6 characters for base 16. So, A represents 10, B represents 11, C 12, D is 13, E is the same as 14, and finally F represents 15. And those are your hexadecimal digits. So we have the hexadecimal number 3F. Well, just like we computed the values of the places for decimal numbers in binary and octal, we do the same thing for hexadecimal. So, beginning on the right side, I have F units of 16 raised to the 1st power. On the left side of my number, I have 3 units of 16 raised to the 1st power. Any number raised to the 0th power is 1. Any number raised to the 1st power is itself. So I have F1s and 3 16s. That would be equivalent to 3 times 16 and plus 15 times 1. Or 48 plus 15 in base 10. So, 3F in base 10 is 63. Now, if I want to show this number in Perl as a hexadecimal number, in other words, if I want to use it as a hexadecimal numeric literal, I would show it as 0x 3F. Remember, the 0x simply means this is a base 16 number. And that is all there is to it.